Alright guys, welcome to this page of the notes. I'm not going to spend a ton of time here because, again, we've already seen this back in chapter 4 and we actually already did a problem here. Don't let the name confuse you. What they're going to do in this chapter is they're going to call it the location principle. That's just a really fancy way of saying consecutive integers. When you don't get a 0 in the range column, you're looking for a sign change. The sign change will let you know between which two integers you cross the x-axis. We call those consecutive integers. And again, this is just a diagram showing you that, right? x1 and x2 are integers. I cross somewhere between those two integers. And the way I know that, well, I was negative at x1. I'm now positive at x2. The only way you go from being negative to positive is if you cross the x-axis. You gotta cross the x-axis to go from being negative to positive, or the other way, from positive to negative. You must cross the x-axis. And so if that doesn't happen at integers, then you know that you have consecutive integers. You've crossed somewhere between two integers. Again, in this chapter, chapter 5, section 4, they call it the location principle. Not that big a deal. I'm perfectly okay with you guys referring to it as consecutive integers because technically that is what you're finding. You just happen to be using the location principle to find those consecutive integers. Once again, just another example problem here where they're showing you the changes in sign which represent your consecutive integers, but you guys already know how to do all that, so let's do a problem. Here's another one. What I've done is I've given you guys a polynomial along with a coordinate plane on which we are going to graph this guy. So we're going to go ahead and jump right into it. The first thing you should do is make sure that it is in standard form. Then figure out your degree, your leading coefficient, so that you know what the end behavior is going to be. So let me take care of that. 4, 3, 2, 1, 0. It is in standard form. That means I have a fourth degree, which means I am even. Even tells me both ends are going to go in the same direction. My leading coefficient is positive. So both ends are going to be headed to positive infinity. What that means is I already know what the ends of my polynomial are going to look like. As x goes to negative infinity, f of x is going to go to positive infinity. And as x goes to positive infinity, f of x is going to go to positive infinity. Again, that's just a fancy way of saying as you go to positive infinity, your polynomial had better go in this direction. And as you go to negative infinity, your polynomial had better be going off in this direction. All right? We know that's what's going to happen. If you get something different in your chart, you made a mistake. All right? Something went wrong. You probably fat-fingered something on your calculator. Go back and try again. Let's go ahead and set up our chart. Again, there is no easy way of doing this. It's just going to be a lot of plugging and chugging on a calculator. Again, I'm going to start at 0. I'll go in the positive direction and the negative direction. You might not need all of these points, but you never know. So just keep going until you get numbers that don't fit on your graph anymore. Or, I'm sorry, that don't fit on the coordinate plane that I've given you. 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Again, it's a lot of plugging and chugging in a calculator, which I already did ahead of time because it just takes a while. 0 is going to be 1. Positive 1 is going to be a negative 2. Positive 2 is going to be a negative 13. Positive 3 is going to be a negative 14. Positive 4 is going to be a, wow, 37. Holy moly, that's quite a jump. Okay, so anyway, I know that both ends have to go to positive infinity. I now have a really large positive number, so I'm going to guess that that guy just keeps going to positive infinity, and in fact, he will. Go the other direction, negative 1. Again, double check these on your calculator, but you should be getting what I get. Negative 1 is going to be a 2. Negative 2 is going to be a 31. And yeah, those guys just keep going. They're just going to keep going to positive infinity, which makes perfect sense. I know that this end's got to go to positive infinity, and that's what I am seeing. Let's go ahead and graph as many of these as I can. All right, 0, positive 1. Okay. Negative 1 is at a positive 2. And then 2 is way up here somewhere. All right, so here's what I've got. I'm going to connect these dots. Both ends are coming from positive infinity, which you can clearly see by way up there. This guy's got to come all the way down to here, and then it looks like I'm going to loop around through there. So as best I can, let's see if I can make this guy look somewhat decent. Okay. Awesome. All right, again, it's a sketch. It's not going to be perfect. Plus, I'm trying to do it on an iPad, so it gets a little wonky on me. But that is a great general idea of what this is going to look like. Now, I will make this quick note. It turns out, if you were to graph this polynomial on a graphing calculator, this is not exactly what the polynomial looks like. However, for the purposes of this question, you're close enough. All right, it's good enough for now. We'll worry about those other little nuances as we get into later sections. For now, you've chosen your domain values, you've found your range values, you've plotted them, you've connected your dots. No, it's not exactly right, but for this it's good enough. It's good enough for now. We'll worry about the graphing calculator stuff later. I did ask you to find zeros, so let's go ahead and do that. I don't have any zeros in the range column, so we're looking for sign changes. I got a sign change right there. Actually, it looks like, oh, nope, and sorry. I do have 2 of them right there. So we'll write our consecutive integers, which are going to be, let's see, between 0 and 1. Between 0 and 1. And between 3 and 4. These are my consecutive integers. And again, how did you find the consecutive integers? You actually used what is known as the location principle. The only way I can go from being negative, a range value that's negative, to a range value that's positive is if I cross the x-axis. Where did I cross between? I cross between 0 and 1. Again, the only way I can go from being negative in the range to positive in the range is if I cross the x-axis, right? That's the location principle, and that happened between the consecutive integers 3 and 4. Guys, that takes care of this problem. Head on over to the next page of the notes, and we'll take a look at another one. I'll meet you there.